This is the geometry ACT prep, and the first thing I'm going to do for those of you who are new is just do a few quick tips. Those of you who were here last time heard these already, but just to refresh, 60 minutes, 60 questions. You would think that meant a minute per problem. Those of you who were here last week quickly learned that they are not, all problems on the ACT are not created equal. The beginning problems are much easier, so they go a lot faster. The end problems are harder. So as you're working through the beginning problems, you want to go a lot faster than you go at the end. Don't spend too much time on any one question. Try looking outside the box. You'll see that a little more today on the geometry than you saw in the algebra. Be familiar with your calculator before you go into tests. I just put some programs on a few of your calculators, and a lot of people get really excited and they're like, yes, I'm going to use programs for everything. You don't want to use anything on the test that you haven't practiced before you go in. Otherwise, it can just be a time waster. So, and also, if you can do it by hand, I think you'll be faster by hand than you would be with the calculator anyway. Bring extra batteries or change your batteries before the test. If you don't remember ever changing your calculator batteries, the ACT is a very inopportune time for your calculator batteries to die. So you may want to change them before you go or take some extras, something like that. Today I am taking my math teacher hat off and putting on my ACT prep teacher hat on, and those two things are very different. You are not answering questions for your math teacher. You don't have to show work. As soon as you know the answer, even if you haven't fully solved the problem, as soon as you know the answer, you put it down. You move on. Put the letter down, move on. It's not for your math teacher, it's for ACT, and all they care is that you get the right letter. If you need to guess, pick a letter and stick with it. Probably the book that I've been using suggests the DJ spot. So just pick a letter and stick with it. Different books will have different suggestions. So today we're going to do geometry, and we will also do some trig, which kind of fits in the geometry section. What that means is we're starting on number 10 in the purple 2012-2013 Preparing for the ACT book. Number 10, if I remember correctly from last time, was that the first geometry one? So, number 10. A rectangle has an area of 32 square feet and a perimeter of 24 feet. What is the shortest side lengths in feet of the rectangle? So the area is 32. The perimeter is 24. So this is a challenging question. Not a piece of cake question like some of them are. Any ideas? Good. System of equations, substitution or elimination, and this one fits substitution. So I'm going to take the first equation. Sorry.
Miss Thill to the junior attendance office, please. Miss Thill to the junior attendance office. Thank you.
Take the first equation and divide it by either x or y, and so I get y equals 32 divided by x. I'm going to substitute that in the second equation. How many of you don't like fractions, particularly in equations? Yeah? What could we do to get rid of the fraction?
Multiply everything by x.
Multiply everything in the whole equation by x. We'll have to know that x can't be 0, but other than that, we're just going to multiply everything by x. So I get 2x squared plus 64 equals 24x. I can divide everything by 2. Get all of the x's on one side. and factor. That is the easiest way to solve that equation, not the only. 4 and 8, multiply to give you 32 and add to give you negative 12 if they're both negative. So x could be 4, x could be 8. Remember, we are looking for the shortest side. So 4 and 8 are actually both sides of that rectangle. Which one is the shortest? Sides 4. Now, this was quite a bit of work. This is the mathematical math teacher way to solve it. What else could I do if that wasn't working out for me? Could you pick the numbers and try them out? So say you picked 1 to be your x, then that would mean y was 8. You could check and see if that gave you a perimeter of 24. And it doesn't. Does everyone know what, or not 8, y would be 32, sorry. If x was 1, y would be 32, and you could see if it gave you a perimeter of 24. Does everyone see what I mean by that? And it doesn't, so you can move on to the next one. You can move on to the next one. And that would also get you the correct answer if this was too difficult. Remember, think outside the box. In triangle ABC, the measures of angle A and angle B is 47. So the sum of the measures of A and B is 47. What is the measure of angle C? What do you know about all three angles in a triangle? They add up to be 180. If you didn't know that, write that down, because that is something you'll see on several problems on the ACT, that all of the angles in a triangle have to add up to be 180 degrees. So I'm going to do 180 minus 47. Type that in your calculator, and what do we get? Good. So D is the correct answer. Any questions about number 11? Okay, the next one is number 17. Hotshot Electronics is designing a packing box for its new line of acoustical Odyssey speakers. The box is a rectangular prism of length 45 centimeters, width 30 centimeters, and volume 81,000 cubic centimeters. What is the height? The volume of a rectangular prism is length times width times height. I know the length is 45. I know the width is 30. I don't know the height, but I know the volume is 81,000. Let me know if I'm going too fast, if you have any questions. Any questions so far? What do I do from here? Good. So multiply the 45 by the 30 and then divide that from 81,000, or just divide 81,000 by 30 and then by 45, either way. And what do we get? 60? Is that right? So far, so good? Any questions so far? 4 points A, B, C, and D lie on a circle having circumference of 15 units. This is one of those where I'm just going to draw a picture and think about it. So I know all the way around the circle is 15 units. It says B is 2 units counterclockwise from A. So if I put A on the circle, B is 2 units counterclockwise. C is 5 units clockwise. And D is 7 units clockwise. I know that halfway is about 7.5. Just mental note. How do I know that halfway is about 7.5? Good. All the way around is 15. So halfway would be half of that. Any questions about that so far? About what I know? So D is 7 units clockwise from A and 8 units counterclockwise from A. What is the order of the points starting with A and going clockwise? So A, C, D, B. Any questions about that? You could probably overcomplicate that, trying to use some kind of fancy math on that. Just draw a picture. I have another booklet that I'm going to occasionally pull from. I won't on that particular one, but there are more problems where just drawing the picture is the easiest way. When we get to the end, I'll go back and look at some of those. The length of a rectangle is 3 times the length of the smaller rectangle. The 2 rectangles have the same width. This is number 20, by the way. The area of the smaller rectangle is A square units. The area of the larger rectangle is KA square units. Which of the following is the value of K? So sometimes you can get lost in the words. Pictures help your brain out sometimes. So I'm going to draw a picture. I have the length of a rectangle is 3 times a smaller rectangle. So I have some small rectangle and some large rectangle where the length is 3 times the smaller rectangle. If you have to, you can put some numbers in. Like say you thought this length was 2, what would this length be? 6, 3 times the other length. And so I know the area of the smaller rectangle is A. So I know this area is A. Remember, A is length times width. Sorry, I did that backwards, didn't I? Length times width. The 2 was the length. The area of the bigger triangle would be 6 times the width. Right? So what would you multiply the first area by to get the second area? 3. So what would the K have to be? Because it's the smaller area times K gives you the bigger area. So what would that letter have to be? 3? Everyone see how I know that that's 3? Does anyone not know how I got that? I can explain it a different way if it's a little bit confusing. Would we tell me if y'all were confused? Number 22. Our first trig problem. Before we start, you need to know this. SOHCAHTOA. The SOH stands for sine of an angle equals opposite over hypotenuse. The C stands for cosine of some angle. This symbol is theta, but it just stands for any angle. It's like an X. It's just a variable. Equals adjacent over hypotenuse. And tangent of an angle equals opposite over adjacent. You need to know SOHCAHTOA for the ACT. A lot of the trig problems can be solved even without having trig, just knowing SOHCAHTOA. So it says the dimensions of a right triangle are shown below. They're given in feet. What is the sine of theta? Sine of theta is the opposite side divided by the hypotenuse side. So from theta, what side would you call opposite of theta? A, because it's the farthest away, it's opposite. Does everyone, even if you haven't had trig, would you agree that A seems to be opposite the angle? So A is opposite, and the other one is hypotenuse. What is the hypotenuse in this triangle? C, so this is A over C. Opposite over hypotenuse because it's sine. Any questions about the first trig problem? There is usually a trig problem where this is all you need to know. So don't skip all the trig problems. This one you want to get even if you haven't had trig. So this is G. Any questions about 22? SOHCAHTOA. Number 27. In right triangle ACE below, Side BD is parallel to AE, and BD is perpendicular to EC at D. The length of A is 20 feet. Sorry, AC is 20 feet. The length of BD is 3 feet, and the length of CD is 4 feet. What is the length of AE? So I want to know this length here. I'm going to call that X. This is a proportion problem. We have similar triangles, so they're proportional. We're going to set up a proportion. There are several ways to do this, but any way that I do it, I'm going to need this length. Does everyone see why I'm going to need that length? Because I know the 20, I need the little length to have a ratio. How can I find that length? Maybe subtract what from 20? Pythagorean theorem on the little bitty triangle. Does everyone see that? The little bitty triangle Pythagorean theorem. So I'm going to do 3 squared plus 4 squared equals the c squared. Now I do want to point out, this is a Pythagorean triple. Has anyone heard of those before? Pythagorean triples are common Pythagorean theorem answers. Those are very nice to know. Are those on that sheet I gave you? If they're not, Google them. They're nice to know. They save you a little time with Pythagorean theorem. I don't remember if they are on here or not. But they would be worth the time to Google them, to know them just right before the ACT. I don't see them, so Google Pythagorean triples. You don't have to, oh wait, yes they are. Under the formulas for triangles, number 4, right triangle combinations or ratios to watch for are 3, 4, 5, 6, 8, 10, 9, 12, 15, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Does everyone see where I'm getting that? The longest side has to be the hypotenuse, but those appear on the ACT a lot. Not that it'll save you a ton of time, it'll just save you Pythagorean theorem time. There is a program, one of the programs I gave you does the Pythagorean theorem, and that is a total waste of time. I wouldn't use it. Just my opinion on that. Is everyone pretty good at doing the Pythagorean theorem? If not, I can show you that program, but I think it's a little bit time wasting. Okay, let's do this Pythagorean theorem, and I get 9 plus 16 equals c squared. I add 9 and 16 together and get 25. And then I take the square root of 25 to get c. So this is c squared equals 25. Square root that, and I get c equals 5. So this side is 5. You notice this is a pretty lengthy problem because we're not at all finished with it. I was looking for side x, and all I found is this third side. So now, I'm going to do a proportion. I know that side x divided by 3 should equal the big hypotenuse, which is 20, divided by the little hypotenuse, which is 5. Corresponding parts of similar triangles are proportional. And so I get 5x equals 60, and x would be, what would x be? 12. So B. Any questions about that one? It had quite a few parts. Big thing, you're going to see a lot of Pythagorean theorem problems, but a lot of times they are Pythagorean triples, so that can save you a little bit of time there. Any questions about that? Number 30. Have I skipped any? Number 30. The sides of a square are 3 centimeters long. One vertex of the square is at 2, 0. I'm going to draw a picture as I go. 2, 0. On a square coordinate grid marked in centimeter units. Which of the following points could also be a vertex of the square? I know they are 3 units apart. I'm just going to start drawing those points. I think that's the easiest way to do this problem. You could overthink it. -4, 0. Is that 3 units away? It's not, right? So it's not that one. 0, 1. That could possibly be 3 units away, maybe. If I did some Pythagorean theorem stuff. I'm going to hold off on that one. Hopefully it's easier than that. If not, we might have to use the distance formula. Most of the time, though, these problems are easier than you would expect. 1, -1, so that would be right here. That's not 3 units away. 4, 1. Again, that could possibly be 3 units away. I'm unsure. But what about 5, 0? That one definitely works. No distance formula needed. That probably means it's the one that works. So just going through those, seeing which one was 3 units away. 5, 0 was easiest. Any questions? Number 31. For FGH, shown below, which of the following is an expression for y in terms of x? This is our second Pythagorean theorem problem. Okay. I know that in the Pythagorean theorem, 1 leg squared plus the x squared, is a squared plus b squared equals c squared, Pythagorean theorem, where the c is the longest side in the right triangle. Questions so far? And I want an expression for y in terms of x. So what do I need to do to get y by itself? To get just plain y. Take the square root, and 4 squared is 16, so I get the square root of 16 plus x squared, which I can rearrange those. Adding is commutative. You can switch them around however you want. So that is E. Any questions about that one? Number 36. This one's kind of an important one because there is an equation that if you know, it'll really help you with several ACT problems or a problem like this on several tests. It's the equation for a circle. You may remember it from Algebra 2. You might have learned it in geometry, but it's the equation for a circle. In general, x minus h squared plus y minus k squared equals r squared is the equation of a circle where the center is hk and the radius is r. I believe that is on your formula sheet on the... You didn't? Well, add it. It is on the back page of the front, back of the front page, in a weird spot. So I want to know from this equation, what are the radius of the circle and the coordinates of the center? Well, if this is r squared, then 38 is r squared. So what would r be? The square root of 38, so it's either either f or j, one of the two. Now I've got to use the center part. The center is at hk, so in this case, Notice the subtract is part of the formula, so the center would be 5, 0. So F is the correct answer. In every released ACT that I have worked recently, I have seen an equation of a circle problem. Let me see if I can show you another one really quick. This is one on last year's released ACT, the 2011-2012 booklet. You don't have this, but if you'll look really quick, this is a formula that's pretty important to know because this is probably one of the easiest problems for a number 55. Remember how we talked about number 55 is normally a tough one. This one's pretty easy. It gives you this picture, and it wants the equation of that circle. The radius is 52. The center is 0, 0. So it's x squared plus y squared equals 52 squared. So all you have to know is the equation for a circle. Definitely worth our time, and you can see that just the last 2 released ACTs have had a circle problem on there, so probably worth your time. Okay, number 37. The figure below consists of a square and 2 semicircles with dimensions as shown. What is the outside perimeter of the figure? Perimeter is the distance around. If this is 8, what's this length here? 8, it's a square, and this length is also 8, which means the radius is 4, half of the 8. I already know that 8 plus 8, which is 16, will be part of my answer, but I need the perimeter of the circle. What's another word for perimeter on a circle? Circumference. The circumference of a circle is 2 pi r. That is also on the back of the front page. 2 pi r. And what is r? The radius. And what is the radius of that circle? 4. Good. So the circumference is 2 times pi times 4, or 8 pi. Notice I'm not going to type that in my calculator with a pi in it. Why am I not going to do that? Good. And what do the answers look like? Sometimes they do approximate, but these have pi's in them, so I'm not going to just type it in my calculator. Now, for this part, I would only want half of the circumference, so I could divide it by 2, but why is it okay that I don't divide it by 2? I have 2 halves. So it makes a whole, so we're okay with that whole circumference. So we have 8 plus 8 plus 8 pi, which is 16 plus 8 pi, or B. Any questions about that one? Number 38. This one I think is one of the more challenging ones. It's one that some of you, as far as time goes, may end up skipping, and that's okay. Remember, skipping is a good option sometimes. If it's going to waste your time, there are 60 problems, you want to get to answer them all. This may be one that you skip and come back to, but we aren't going to skip any because the point of this is to learn how to do them all. In the figure below, E and F are midpoints of the sides AD and BC of rectangle ABCD. Point G is the intersection of AF and BE, and point H is the intersection of CE and DF. And you'll notice a lot of times their words just explain the picture, and so kind of pay attention to that sometimes. What is the ratio of the area of EFGH, which is the inside part, to the area of the shaded region? So I need to know the ratio of the inside part to the area of the shaded region, which means I somehow need to find an equation for the area of each one. So the thing that I know, there are a couple of things. If I have the length of this whole rectangle, this part would be 1/2 of the length. Sorry. So that part would be 1/2 of the length. Does everyone see how I know that? Which means if I broke this into 2 triangles, this part would be 1/4 of the length. Does everyone know how I got 1/4, 1/2 of the half? So this is 1/2 and this is 1/4. And doesn't say anything about the height, does it? Or the width? I don't think so. So I want to find the area of the inside piece. The area of a triangle is 1/2 base times height, and I can see if I use the width that the area of that triangle would be 1/2 times 1/4 times length times width. That's just the area of this one little triangle. I really would like the whole piece, so wouldn't it be 2 of those? So the area of the white piece is 2 times 1/2 times 1/4 times length times width. So the area of the white, which is the 2 times 1/2 cancels, and I get 1/4 length times width. That's the area of the white piece. The area of the whole rectangle is length times width. But I don't want the ratio of the whole, I want the ratio of the shaded region, the white part to the shaded region. So, to get the shaded region, that would be length times width minus 1/4 length times width. Does everyone know how I got that? So length times width, so the shaded would be length times width minus 1/4 length times width, which would be 3/4 length times width. So it's 1/4 to 3/4 is my ratio, 1/4 to 3/4. And as you know, just like a fraction, we can kind of reduce those. So it's a 1 to 3. 1/4 to 3/4, or 1 to 3. Any questions about that one? I think that one was very challenging.
Just look at it and tell if there's one of the white ones, and it makes 3 of the other ones.
Good question. The only thing you have to be careful about is that you don't know for sure that that this one and this one are the same. You know what I mean by that?
I mean, like that one, and then the one on the other side of that, and then the 2 in ones, and then the 2 on the bottom.
Like counting?
Yeah.
Yeah, that's what I mean though. I don't know that this one and this one are the same. Now, for ACT though, I mean, if it works for you, it works for you. Mathematically, I don't know that it would always work out. But does everyone know what I mean by that? By the, I don't know that all of the triangles are the same size. But does it work? Let's see, 1, 2, 3, 4, 5, 6. Yeah, it does work though. 6, because you would get 6 to 2, which would be 3 to 1. So, I'll think about it mathematically. I think since I don't know if these triangles and these, yes, and maybe it would always work. That would be the one thing I'd be afraid of. But again, on ACT, remember it's not for your math teacher. So if it works, the fastest way that you get the right answer is the right way to do it. Okay, let's look at the next one. 39. Coordinates of the endpoints of CD in the standard XY coordinate plane are -4, -2, and 14, 2. What is the x coordinate of the midpoint? So let's talk about midpoint formula. This is also on most ACTs. Let's be more generic. The midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Or another way to think of it is averaging the x's and averaging the y's, finding the middle. -4 plus 14 divided by 2 and -2 plus 2 divided by 2 would be the whole midpoint. But I would be wasting my time to find the whole midpoint. Why? It only asks for the x coordinates. So I'm only going to do the first part of that.
I know. Wait to pick up the foot down.
-4 plus 14 is 10 divided by 2, so I get 5. Now this one was a pretty straightforward midpoint problem. I want to go back to an older ACT and show you another way they could ask a midpoint problem that's a little bit more complicated. Again, this one's back to last year's book, so you don't have this in your booklet. Number 9 on this one. Zoom in a little bit. In the standard XY coordinate plane, point M with coordinates 5, 4 is the midpoint. So this is the midpoint. And point B has coordinates 7, 3. What are the coordinates of point A? How is this one a little more difficult? That it kind of switches the equation around. Instead of looking for the midpoint, I'm looking for one of the points. So if I were looking for the x coordinate, I would do 7 plus the other x divided by 2, and I know that would equal 5. So in this one, I end up kind of having to do an equation. So another way a midpoint problem could be asked. I could multiply by 2 and get 7 plus x equals 10, subtract the x and get, or subtract the 7 and get x equals 3. And this is where, remember, you're not working a problem for your math teacher. I would stop when I did that. Why? Now, there's only one problem where x is 3, or one answer where x is 3, so I'd stop there and go with that. While we're sitting here on this booklet, this is another problem I like to show you the thinking outside the box, which some of you have kind of already started doing that. In this rectangle, what are the coordinates of the other point is essentially what it's wanting. You could do some math to try to use slope and parallel lines to find the other coordinate. But the fastest way to do it is very carefully drawing a rectangle. And you do have to be very careful because they do put a pretty good distractor. But it's still faster. Being very careful is still faster. Okay, and so after I draw that rectangle, which one appears to be the correct answer? F, right? So if you're a careful drawer, F is the correct answer. 9, -2 is a pretty good distractor, but if you draw it careful enough. So that's a good example of one that is just draw the picture, think outside the box instead of trying to overcomplicate with math. One other one while we're on this page that I like to show, again, not in your booklet. Given the triangles shown below with exterior angles that measure x degrees, y degrees, and z degrees as shown, what is the sum of x, y, and z? The most common way to work this problem, and I want to show you that first, the most common way to work this problem is to first find this angle right here, doing 180 minus 72 minus 57, you get 51. And then doing 180 minus 51 to get angle Z. And doing 180 minus 72 to get angle Y. And 180 minus 57. 123. to get angle X. And then add the 3 up and you get 360. Not that that was particularly challenging, but it did take a little bit of work. There is a geometry theorem that says the exterior angles in any polygon had to be 360. So if you remembered that geometry theorem, which unless you're in geometry, probably not, you would have worked it that way. But that's a theorem that you might want to, you know, oh yeah, I remember that theorem. So in any polygon, could be a rectangle, square, whatever. The exterior angles in any polygon, all of the exterior, that one's probably a hard picture to see. Let's do a, all of these angles add to be 360. And one of the ways you could think of that is all the way around adds to be 360. So anyway, just some problems that are good ones to know. Number 40. What is the surface area in square inches of an 8-inch cube? What is surface area?
6.
The area of all the faces. And you may know that a cube has 6. If not, that's okay. Just envision a Kleenex box or something that's square, not like this one on my desk, but another one. I'm going to draw a picture of a cube. Not a very good picture. Should have. Let's make that. Okay, so we have a cube that is 8 inches on each side, and I want to know the surface area. The area of one of the faces would be 64. Does everyone know how I knew that part? 8 times 8. And then I'm going to look, I've got the top one and the bottom one and all 4 sides, so there's 6, and I'm going to multiply that by 6. And you get 384 G. Any questions about that one? Number 42. Am I going too fast? Okay. According to the measurements given in the figure below, which of the following expressions gives the distance from the boat to the dock? So I want to find this distance. Notice I have an angle, and you may quickly look at the answers and notice sine, cosine, and tangent in the answers, which means we're doing SOHCAHTOA again. If I look from the 52, the x, would you agree that the x is the side opposite the 52? So I'm looking for opposite. I have the side right beside the angle, and I know that this side is the hypotenuse. So from the angle, this one is the adjacent, this one is the opposite, and this one is the hypotenuse. So I want opposite, I know the adjacent, so that's tangent, opposite and adjacent. So the tangent of 52 equals x over 30, opposite over adjacent. And I can multiply by the 30 to get x by itself, so 30 tangent of 52 equals x. So the second SOHCAHTOA problem, and there may very well be 3 of them on the ACT. There are usually at least 2 that involve SOHCAHTOA. Any questions about that one? Does SOHCAHTOA make sense to everyone? Number 44. Lines of symmetry. Notice this says, use the following information to answer questions 44 through 46. Anytime it says that, pay attention. Occasionally, not very often, but occasionally, there will be one on the next page that still goes with one picture. And sometimes we can get really confused and think we don't have enough information, so make sure you pay attention to what the information goes with. The design of the stained glass panel has how many lines of symmetry in the plane of the panel? So I want to know lines of symmetry. If I start drawing lines of symmetry, line of symmetry is anywhere I could fold it in half and it looked the same on each side. Does everyone see how I'm getting these lines of symmetry? So there are 1, 2, 3, 4, 5, 6, 7, 8. If I keep going, I start recounting. So 8. Any questions about that one? Lines of symmetry question. What is the area of the stained glass panel? To the nearest 1/10 of a square foot. This whole thing is the stained glass panel. It says the design of the circular stained glass panel, so the circle is the panel. I want to know the area. What is the area of a circle? Pi r squared. That's another formula you need to know for the ACT. Circumference, 2 pi r, area, pi r squared. And so the radius, what is the radius? Good, so since the diameter is 2 feet, the radius would be 1. So the area is pi, which if you type pi in your calculator, you'll get 3.1416, all that fun stuff. So the area is a square feet. Any questions about that one? Number 47. In the figure below, AB and CD are parallel. AE bisects angle BAC, which means if an angle is a bisector or if a line bisects, that means cuts in half. So this angle and this angle are the same. And CE bisects ACD, which means this angle and this angle are the same. If the measure of angle BAC, this whole angle is 82, what is the measure of angle AEC? So this whole angle is 82, which means the little angle is 41. How do I know that? Half. Good, it was a bisector. Now, just for a second, we're going to take a side note and talk about parallel lines cut by a transversal. If you remember geometry, this was a big deal. You may not remember all of the names, and that's really, as far as the ACT goes, okay that you don't remember all the names. For your math class, you might need to know them. But I just need to know which parts in two parallel lines cut by a transversal are equal. And this is a very non-mathematical way to think about this, but we're going to learn it that way just for ease. Notice this angle is acute and this angle is obtuse. Normally you will have one acute and one obtuse angle. In two parallel lines cut by a transversal, all of the acute angles are equal, all of the obtuse angles are equal. Alternate interior, alternate exterior, consecutive interior, all that fun stuff that we learned. All the O's are equal, all the A's are equal. Oh, I forgot to know. Also, an O plus an A equals 180. So you may have remembered, like, consecutive interior angles are supplementary. They add to be 180. Any of the pairs, since they make a line, add to be 180. Why is that important to my problem? You see these parallel lines cut by this transversal? This whole angle here is 180 minus 82. Does everyone see how I know that? This whole angle here is 180 minus 82. So that whole angle would be 98. Does everyone see where I'm getting that from? And 98 divided by 2 is 49. So each one of these little angles is 49. Now this is the way I saw it first. You may have seen something else, which is also okay. If you saw a different way to work this, that's wonderful. The thing that I'm looking for is angle AEC. AEC, which is angle E. I know the angles in a triangle add to be 180, so I'm going to do 180 minus 41 minus 49. What is this, the third time we've had to use that piece of information, that all of the angles in a triangle add to be 180? It's an important piece of information. So angle E is 90 degrees. Any questions about that? The next one, those of you in upper level math, this one's a good one for you to really pay attention to. Not hard, but probably forgotten if you have been out of geometry for a while. In the circle below, chords TR, QS intersect at P, which is the center of the circle, and the measure of PST is 30 degrees. What is the degree measure of the minor arc RS? So I'm looking for the degree measure of RS. And the theorem that you need to know is how to find the measure of an arc. It's easier than that. Geometry before that. If you know two chords that intersect on the circle, then this angle is half of this arc. So this is 60 degrees. This angle is half of the arc. Do y'all remember learning that? It's been a long time, I know. So you don't remember it all? So this one's a good one to look at. So then the next piece of information we need to know is that central angles, if we intersect at the center of the circle, equal the intercepted arc. So if this is a 60-degree arc, then that is a 60-degree angle, which means this one's 60 degrees by vertical angles, which means this one is 60 degrees. So H is the answer. I think the central angle one you probably remember. To me, that one's, you know, the central angle equals the arc. But and I don't even remember the name of that theorem, but when two chords intersect on a point on the circle, this angle is half of the intersected arc. So good one for those of you who haven't thought about that stuff in a very long time.